Often, we hear that cues follow a certain hierarchy, where the verbal is said to provide the lowest level of support, and physical gestures are said to constitute the highest support. However, there is an essential problem that I usually encounter with this kind of model. Let's say I am pointing to an animal, a dog, and I am asking my student what it is. Would physically gesturing towards the dog or acting out how it looks like constitute the highest support for the response that I'm expecting from him? Or if I use phonetic cues, which is um, essentially part of verbal cues, would that mean that I am using a low level support system even if I am modeling the word already? I would like to think not. The quest to find a more precise framework for viewing cues and prompts would bring us to the paradigms we use to understand or for understanding memory processes. Memory is said to have three stages. First, the encoding stage. This is the process of receiving stimuli and working on distinguishing its features. Repeated exposure to these stimuli triggers the process of consolidation, where information initially found in temporary storage moves towards a more permanent one. This is what we know to be long-term memory, or LTM, which is a neat storage of information where each unit is tagged based on how it relates with all other units. Stored information are accessed or retrieved later on from the LTM whenever situations call for it. When we ask our client to respond, we are either providing them with a prompt to perform the steps of the task at hand, or we are attempting to entice them to retrieve a specific piece of information by presenting what we call cues or triggers related to the expected response. Now, in this slide, we see that the long-term memory store of the man contains related units such as the dog, an acoustic map probably of the barking sound or the label dog, a doghouse, a collar, a bowl of kibble, and bones. Externally, if the man sees within his perceptual field a doghouse, a collar, a bowl of kibble, and the bones, these four items would serve as triggers or cues for him to remember the dog, or maybe its bark, or its name or label. The four items found in the environment may entice the man to actively search for the dog or to ask, "Where is the dog?" The process of retrieving related units of information given cues or triggers coming from the external environment is what we term to be cued recall. So we know now that cues are units of information coming from the external environment, which then triggers the memory retrieval of related units of information. These are tools we use to extract information that has been stored in the LTM. Given this definition, we could then say that stimuli are essentially cues precisely because they trigger the memory of related units of information. Because they are triggers, then a response is usually expected whenever a stimulus is presented. However, it is not always that the stimulus is compelling enough to trigger a response. Thus, more cues are added to it so that it increases the probability of eliciting the process of cued recall. As a general rule of thumb, the more closely similar the cue is to the response, it is said to be the strongest trigger for the retrieval of an expected output. The first thing we usually consider here is what type of neural signal is the expected response. Is it visual, or acoustic, or tactile, or kinesthetic, or some other sensory signal? Knowing the type of neural signal the expected response is would help us define exactly what the modeled output should be. If, for instance, the expected output is visual verbal, then we know that we need to model how it is to write the word. Okay? If it is verbal acoustic, on the other hand, then we know that we need to model how the word is said. If the expected output should be non-verbal kinesthetic, then our model should include the specific movements involved in what would be considered the correct response. Once we identify the type of output, we then ask ourselves, what sort of experience does my client have of the concept that I am trying to trigger? This will allow us to identify how many possible units of information about the concept is stored in the LTM. Now, when we use these units of information as cues to trigger the response, each unit of related information is said to increase the magnitude of the cue being given. Now, heading on over to frequency, we ask ourselves, how many times are the stimuli and cues, or should the stimuli and cues be repeated such that information being received enters into the process of consolidation? So, just to reiterate what has been mentioned in the earlier part of our discussion, consolidation is when information from temporary storage upon repeated exposure transfers to long-term storage. Increasing the frequency by which a cue is repeated, though, does not necessarily increase its magnitude. Instead, it helps the individual consolidate information enough to access the long-term memory stores. So here is an example. Showing the photo of a dog, the clinician asks, "What is this?" This comprises the stimulus, or what we might consider to be the first cue, which should trigger the word dog, which is verbal acoustic in nature, in terms of neural signal, the type of neural signal. If the expected response is not obtained after asking the client, showing the client the picture and then asking, "What is this?" If there is no response given, the clinician then repeats the stimulus and then adds another cue. Okay, so shows the dog again, then asks, "What is this?" Then says, "It says woof woof." If no response, if there's no response still, the clinician repeats the previous set of cues in an attempt to drive the brain to consolidate, then adds another cue to in turn increase the magnitude. So take note that the previous sets of cues are repeated. Okay, the frequency is increased to help the brain consolidate, be driven into consolidation. Then, in order to increase the magnitude, we add another cue or a related piece of information. So here in the slide, as shown in the slide, it would be showing again the picture of the dog asking, "What is this?" It says, "Woof, woof." It eats here. It wears this. It is a. Okay. So when we enter that portion of the cue, it is said that we are essentially saturating the frequency and the magnitudes by which we deliver cues to the child. But if the response still remains unretrieved, here is where we start to add cues that move now towards the modeling of the response. So in this case, first it would be the. Okay, we say it is a d, and then we follow it up with it is a do, and then finally we fully model the response by saying it is a dog. Now, given these anchors to memory processes, we are apt to rethink our definition of what minimal, moderate, and maximal cues are. So to reiterate, as the cue approaches a full model of the expected output, it is said to increase in strength in terms of triggering the intended response. As such, a minimal cue is anything that presents related information without necessarily modeling any part of the response. Okay. Now, as you can see in the slide, there are numbers, but the assignment of these numbers would depend on the conventions set by the team for scoring. Given these conventions, one can set exactly how much of the response should be modeled in order for one to consider a cue to be minimal, moderate, or maximal. Now, in this case, in the case of the slide, the protocol set is that first, it is considered a minimal cue if less than 50% of the intended response is modeled. Second, it is considered a moderate cue if more than 50% of the response is modeled. And third, it is considered a maximal cue if 100% of the response is modeled. Considering that the expected response is verbal acoustic in nature, which is, in our case, the word dog, we then know that there are three component phonemes where saying "d" would constitute 33% of the expected response, saying "do" constitutes 66%, and modeling outright the word dog constitutes 100% of the expected response. So, as again, it entirely depends on the team, agency, or institution as to what rules it would set for scoring based on cues. As clinicians, it is important that we also have scoring rules set for cued responses because the client runs the risk of consistently obtaining scores of 0 across time if only the spontaneous responses are considered. But what is a prompt? Okay, while a cue triggers the retrieval of a response, A prompt is when we provide the client direct or explicit instructions on how to move step by step from processing the stimulus up to producing the response. An example of this is to tell the client to look or to listen after the stimulus is presented, or to listen to the question, or write or say the answer when he or she is ready to formulate an output.